Hello students, once again. Now we have completed all the theorems and we are going to start with the first of all examples, and after that we will start with the exercise. Okay. Now in the examples, the starting example, the examples 1, 2 and 3 are a bit easier one. Okay. You will not have lots of trouble with that, but shortly after that the difficulty level of examples will increase. Okay. So please pay attention and please follow closely what I am teaching you. Secondly, same with the exercise, the starting 2-3 questions, 4-5 questions are quite easy, but as we move on with the exercise, the each and every question become difficult. Okay, so pay attention from the starting so that you have a solid base on which you can develop your future concepts. Now we'll start with example 1. There is no diagram given. It may be case for many of the questions, so we will draw the diagram and write down what is given to us, what is to prove, and do the solution. First of all, for example number 1, it is given that show that each angle of a rectangle is a right angle. We have learned this again and again, that each and every angle of a rectangle is a right angle. But this time we have to prove this statement. We have to prove that ABCD is a rectangle. Okay. So once again, what is the definition of rectangle? Both pair of opposite sides are equal. Okay. That is the definition of parallelogram. Both pair of opposite sides are equal. Both pair of opposite sides are parallel. And secondly, the important part, how does a rectangle differ from a parallelogram? It is both of its diagonals are of equal length. Both of the diagonals of a parallelogram are of equal length. So we are going to use this very property to prove that our given rectangle have all angles as right angle. Okay. So see carefully. ABCD is a rectangle. Okay. Students, in this chapter, as we have done in theorem, and so we will do in questions, we might be required to prove once again the properties of the parallelogram, rectangle, rhombus and square that we have already learned. Okay. So keep this in your mind when we are proving certain properties of a rectangle or any type of quadrilaterals. It is important for us to understand that we cannot use that very property to prove that very statement. Okay. We have to use different properties to prove that statement. Okay. So ABCD is a rectangle, fine and good. To prove that all the interior angles are right angle. Okay. And then construction will be join AC and BD. Okay. Once again, most of the question that we will be doing, we will be using the procedure of congruency. See, in proof, we are going to take two triangles, in triangle ABDC and triangle BDC. ADC, this one, and BDC, this one. Okay, we are BDC. We are going to take these two triangles. So for these two triangles, first of all, length AD and BC are equal. Why? opposite sides of parallelogram, opposite sides of rectangle are equal. Okay, that is why AD length and BC length will be equal. Secondly, your DC length is common. Okay, and lastly, we know that diagonals of a rectangle are equal. So, AC and BD are also equal. So in that manner, by SSS congruency, both the triangles will be congruent. Triangle ADC will be congruent to triangle BCD, and by CPCT, corresponding angles will be equal. What are the corresponding angles that I am interested in? As though there will be 3 pair of angles are equal, but what I am interested in is angle D of triangle ADC and angle C of triangle BCD will be equal. Angle D will be equal to angle C. Okay, so we will build on this one. So we will build on this one only. Okay, so what will we do is, now since lines AD and BC are parallel, okay, why? Because opposite sides of rectangle are parallel. Okay, that means angle D plus angle C is equals to 180 degree. What I am trying to say is, these two lines are parallel, this is a transversal. So I am saying that these two angles should be equal to 180 degree. Sum of these two angles should be equal to 180 degree. So angle D plus angle C is 180 degree. Why? So co-interior angle. These are pair of co-interior. These are pair of co-interior angles. Okay. So by using these, let angle D and angle C will both be equal to X. So X plus X is 180 degree. That means 2X is also 180 degree. That means X is equals to 90 degree. That means angle D and angle C are both equal to 90 degree. And we know opposite angles of parallelogram are equal. That means angle C and angle A are equal. Angle D and angle B are equal. That means all the interior angles of the rectangle are 90 degree. So we'll write it as, also opposite angles of a parallelogram are equal. Opposite angles of a parallelogram are equal. That means angle B is equals to angle D is equals to 90 degree, and angle A is equals to angle C is equals to 90 degree. So in that manner, all the interior angles of rectangle are right angles. All the interior angles of a rectangle are right angles. Okay. So in that manner, we have proved that all the interior angles of a rectangle are right angles. In order to prove that, we have used the properties of parallelogram. What the property we have used? Opposite sides are parallel, opposite sides are equal. And we have used one property of rectangle, that is both of its diagonals are equal. Okay. By using these two properties and proving triangles congruent, we have proved that all the interior angles of a rectangle are equal and are equal to 90 degrees. Next is example number 2. Example number 2 is show that the diagonals of a rhombus are perpendicular to each other. So once again, we have learned that diagonals of a rhombus are perpendicular to each other when we discuss about the rhombus. But once again, we have to prove this property. So let us make a rhombus. What is a rhombus? Rhombus is a quadrilateral in which all of its sides are equal, or you can say rhombus is a parallelogram in which all of its sides are equal. Something like this. Okay, and let us name it A, B, C, D. What is required of us is diagonals of a rhombus are perpendicular to each other. That means we will be requiring the diagonals of this rhombus. So let us draw them as well. This is diagonal AC, this is diagonal BD. We need to prove that angles at point O are all of 90 degree. Okay. Now, in order to take angles at point O as 90 degree, what I am going to do is I am going to prove that adjacent triangles in this rhombus are adjacent triangles in this rhombus are congruent. So what are the adjacent triangles in this rhombus? I will take angle ADO and triangle AOB. Okay. What I am going to do is, first of all, I will prove that these two sets of triangles are congruent. Okay. Secondly, I will prove using CPCT, I will come to know that these two angles will be equal. Thirdly, on line DB at point O, sum of all the angles at either side of the line will be 180 degree. That means sum of these two angles will be equal to 180 degree. And using that, I will prove that angle AOD and angle AOB are both of 90 degree. Okay. So we will start with this. Given, we are given that ABCD is a rhombus. Okay. Rhombus, what is a rhombus? Rhombus is a parallelogram with all of its sides equal. Okay. To prove, we need to prove that diagonals are perpendicular to each other. We need to prove that diagonals are perpendicular to each other. So we'll start with the proof. In triangle AOD and triangle AOB, we are going to take these two triangles only. In these two triangles, see, first of all, length AD and length AB are equal. This side and this side are equal. Why? Because all sides of rhombus are equal. Secondly, we will have side AO and AO, this side as common. Thirdly, length DO and BO will be equal as well. Length DO is length DO and BO will be equal as well. Why so? Length DO and BO are equal. Why so? Because we know that for a parallelogram, diagonals bisect each other. For a parallelogram, diagonals bisect each other. Okay, so in this manner we have by S congruency. By S congruency, what we have is triangle AOB will be congruent to triangle AOD. Okay, by CPCT you can prove two things. First of all, you can prove that this angle and this angle are equal. That means this OC will be angle bisector of angle A. See students, inside a rhombus and a square only, the diagonals of these two are also bisectors of their interior angle. Okay, the diagonals are not bisectors of interior angle in in rectangle and parallelogram. In rhombus and squares only, the diagonals are bisectors of interior angles. Okay, now in triangle AOB and triangle AOD, in these two triangles, angle AOB will be equal to angle AOD by CPCT, and we will let that both of these angles are equal to X. Okay, now on line BD at point O, on line BD at point O, sum of these two angles will be equal to 180 degree. Angle AOB plus angle AOD should be equal to 180 degree. Why? Linear pair. Okay, so X plus X is 180 degree. That means 2X is equals to 180 degree. That means value of angle X should be equal to 90 degree. Okay, and finally we will write down implies that angle AOB is equals to angle AOD is equals to 90 degree. Hence, diagonals of a rhombus are perpendicular to each other. Diagonals of a rhombus are perpendicular to each other. Okay, so that's all for today. We have completed two theorems and last two theorems of this exercise, and as well as we have started with the example. Try to do example number 3 by yourself. Okay, otherwise if you are able to do it, then it is good. If you are unable to do it, then inform me, so I will do it in my next video. Thank you for your time. Have a nice day.